How will this surface area change if we halve the height of the cylinder? Can you see the two circles have not changed in area? Only the height has changed, and this changes the area of the rectangular part of the net. We will get half of this number. Added to this number, the answer is about 353 squared centimeters. You can check my workings on a calculator. So this cylinder has a surface area of about 620 square centimeters. This cylinder with half the height of the other one has a surface area of 353 square centimeters. That's more than half of 620. Although the height is halved, that doesn't make the surface area half of the bigger one. Now let's have a look at what happens if we halve the radius of the cylinder. Our new cylinder will have a radius of half of 3,7 centimeters. That's 1,85 centimeters. Let's stop here and think about this. What do you expect to find? Make a conjecture about the area of the smaller circle. A conjecture is an informed opinion that you wish to show to be true. How much smaller is it than the original circle? The area of the new circle is pi times r squared, which is 3,14 times 1,85 times 1,85. That comes to 10,75 square centimeters. The big circle was 3,14 times 3,7 times 3,7. That's 43 square centimeters. The area of the small circle is 4 times smaller than the area of the circles on the bigger cylinder. Did you notice that we squared the radius to find the area of a circle? So squaring a half times the radius will make a quarter times the radius squared. So the whole surface area of this container will be the area of these two circles. That's 2 times 10,75. And now, what about the surface area around the cylinder? What do you think we will find? How much smaller do you think this surface area around the container is than the area on the original cylinder? Well, the height is the same, but look at this net of the cylinder. This length here is smaller because it is the circumference of the smaller circle. Let's work it out. So the total surface area is smaller when you halve the radius of the circle than the total surface area when you halved the height. That's fascinating, don't you think? If we have another look at the formula for the surface area, this actually makes sense. Can you see that the value of the radius will affect this term in the formula and this term? But the value of the height only affects this part of the formula. So a decrease of the radius is likely to have a greater effect on the total surface area than a similar decrease in the height.